Okay, now let's see indefinite integration. Now integration is just reverse process of differentiation. So if we have function f derivative is equal to capital Fx, then we write capital Fx integration is equal to Fx. Also we know that if Fx plus c function is differentiated, then derivative of constant function is c. Then if this derivative is capital Fx, then we write integration of capital Fx is small fx plus c. Here c is any real number. Since this c is not fixed, that's why we call this integration as indefinite integration. For example, sin x function derivative is cos x, then we write integration of cos x with respect to x is sin x. Also d by dx of sin x plus c is equal to cos x, then in general we write cos x integration is sin x plus c. This c is called constant of integration. Now as we know integration is reverse process of differentiation, let's list down all the formulas of integration from the formulas of differentiation. Let's start with trigonometric function. This implies integration of cos x is equal to sin x plus c. Derivative of cos x function is minus sin x. This implies integration of sin x function is minus of cos x plus c. Derivative of tan x is secant square x. This implies integration of secant square x is tan x plus c. Then we have derivative of cot x, which is minus cosecant square x. This implies cosecant square x dx is equal to minus cot x plus c. Similarly, we can list down all other formulas like integration of secant x tan x is secant x plus c, because derivative of secant x is secant x tan x. Integration of cosec x multiplied by cot x is minus cosecant x plus c. So these are all trigonometric functions. Then we have inverse trigonometric function. Integration of 1 upon square root of 1 minus x square. Okay, any function which has derivative this, that is sine inverse. Hence integration of this function is sine inverse x plus c. We can replace sine inverse by pi by 2 minus cos inverse x. Now this pi by 2 is constant, c is also constant. They add to have another constant. Say that constant is also c. So we have integration of this function is either sine inverse x plus c or minus cos inverse x plus c. Then integration of 1 upon 1 plus x square. We know that derivative of tan inverse function is 1 upon 1 plus x square. Hence integration of this function is tan inverse x plus c or minus cot inverse x plus c. Then integration of 1 upon modulus of x square root of x square minus 1. This has value secant inverse x plus c or minus cosec inverse x plus c. So these are all inverse trigonometric function integration. Then x power n power function. This has integration x power n plus 1 upon n plus 1 plus c, because if we differentiate this we get x power n. Then we have integration of exponential functions like a power x, that is a power x upon logarithm of a to the base e plus c, because when we differentiate this function we have a power x multiplied by log a upon log a get cancel out, hence we get derivative a power x. Then e power x integration will be e power x, because log e to the base e will be 1. Then we have 1 upon x integration. Now we know that function whose derivative is 1 upon x is what? Log x. In fact, derivative of log of minus x is also log x. Hence we write integration of this as log of modulus of x plus c. These are some elementary integration formula. Let's try some question based on this elementary formulas. For example, let's start with power function. Integration of x power 2 by 3. Then we write x power 2 by 3 plus 1 upon 2 by 3 plus 1 plus c, that is x power 5 by 3 upon 5 by 3 plus c. Suppose we have this function a power mx b power nx. Now integrate this. Any idea how this leads to standard formula? Now obviously this is a exponential function. Can we write this like a power m multiplied by b power n power x dx? For time being we can consider this as suppose some constant c, then this is c power x dx, and from the standard formula of integration of exponential function we have this is c power x upon log c to the base e plus c. Now we can put here value of c, that is a power m multiplied by b power n power x upon log of a power n times b power n plus c, constant of integration. Here this c is this constant, it has nothing to do with this constant, it is coincidentally we have taken this c. Okay, now there are some theorems on integration. Some elementary theorems are integration of k fx. This is equal to k times integration of fx. Okay, then integration of f1x plus minus f2x. If we have addition or subtraction of function, then integration is distributive over this operation. We write integration of f1x plus minus integration of f2x. The same sign is here, the sign what we have on the LHS. Now keeping this in mind, let's try this question. Okay, this is NCERT question. Now we can expand this like x square minus 1. Now we can distribute integration over subtraction, or we can write integration of x square minus integration of 1. Now from the power function formula, integration of this function is x cube by 3, and constant function integration क्या होगा? 1 is derivative of x, then integration of 1 will be x plus constant of integration. Let's try this one, another NCERT equation. Root x minus 1 upon root x square. Obviously इसमें हम क्या करेंगे, पहले expand, then squaring we have x plus 1 upon x minus 2. Then we have x dx plus dx upon x minus 2 dx. Integration of this function is x square by 2. Now 1 upon x, क्या होगा इसका इंटीग्रेशन? log of modulus of x. Okay, 2 इंटीग्रेशन के साइन से बाहर आ जाएगा. This is in fact 2 times 1 dx, and integration of this function is x, then we have minus 2x and then constant of integration. So these are some algebraic function integration using elementary integration formulas. Let's try some trigonometric function. For example, integrate tan square x with respect to x. Now we don't have any elementary formula for tan square integration, rather we have for what? Secant square. Then we can write tan square as secant square x minus 1, and this is secant square x dx minus 1 dx. Integration of this function is tan x. This is standard formula. Integration of 1 is x. Hence this is the answer. We have this one. Integrate tan x upon secant x plus tan x. Any idea? Now we know the identity that secant square x minus tan square x is equal to 1. So if we multiply numerator and denominator by secant x minus tan x, we have tan x multiplied by secant x minus tan x, and in denominator we will have 1 because we will have secant square x minus tan square. Now this is secant x tan x minus tan square x. Now this is standard formula. This is formula for secant x tan square. Just we done this, we can write this as secant square x minus 1. Then this is secant x minus integration of secant square x is tan x and integration of 1 is x. Finally C, constant of integration. Try this question, one NCERT question again. 2 minus 3 sin x upon cos square x. Okay, we must understand the arrangement here. If we keep eye on trigonometric function, we can separate this to 2 upon cos square x minus 3 sin x upon cos square x. Now this is 2 secant square x dx, and sin x upon cos square x can be written as secant x multiplied by tan x. We can take out 2 from here, outside integration sign. This is tan x and this is secant x plus c. Okay, one question on a trigonometric function. Integrate secant square x cosecant square x function. Okay. Any idea for this? We know integration of secant square x separately, that is tan x, integration of cosecant square, that is minus cot x. This does not mean that this is tan x multiplied by minus cot x. That is absurd. Also we cannot convert this into cot square, tan square, and this in cot square, because there are no formulas of integration involving tan square x and cot square x. So we are left with one option only, convert this into sine and cos. Okay, any idea now? Okay, here we have one invisible. Obviously we have made this visible for what purpose? To write this as sin square x plus cos square x. Okay, now is it visible? Sin square of x upon this is secant square x, and cos square x upon this will be cosecant x square. Now these two are by standard formula tan x minus cot x plus c. So this is a bit typical that students don't get idea to convert this into sine square and cos square and writing 1 as sine square plus cos square. Then we have cos x upon 1 minus cos x. Again, this is NCERT exercise problem. We cannot use here right now 2 sin square x by 2 formula, उससे कोई एडवांटेज नहीं होगा. बेटर है कि हम फंक्शन को किस फॉर्म में रखें, x एंगल के फॉर्म में ही रखें. We can go by this way, multiply numerator and denominator by 1 plus cos x. Here we have 1 minus cos square x. Then this is obviously we will separate this. Cos x upon sin square is written as cot x multiply by cosecant x, and cos square x upon sin square can be written as cot square x dx. Integration of this is minus cosec x, and integration of this function is minus, in fact cot square x is not a derivative of any function, rather we write cosecant square x minus 1. Now this is cosec x plus integration of this function is minus cot x, 1 integration is x plus c. Okay, integrate this one, x square upon 1 plus x square. Any function which has derivative which has 1 plus x square in denominator, that is tan inverse x. So keeping that in mind, we must have here 1. Now x square upon 1 plus x square is called improper fraction because degree of numerator and denominator are same. In fact, what are improper fraction? When numerator degree is equal to denominator degree or more than denominator degree. Which are proper fraction? In which numerator degree is less than degree of denominator. So in integration, we first convert this improper fraction into proper fraction, obviously by what? Division. But here division is simple, like adding and subtracting 1. Now this is 1 minus 1 upon 1 plus x square. Integration of 1 is x, and integration of this function is tan inverse x plus c. Let's try one more question. All of you try this one. Integration of x power 6 plus 1 upon x square plus 1. This is simple rather, because we can factorize this as a cube plus b cube. What are factors? X square plus 1 multiplied by x power 4 minus x square plus 1 divided by x square plus 1. This cancels out. We are left with x power 4 minus x square plus 1. Okay, and integration of this is x power 5 upon 5 minus x cube upon 3 plus x plus c. Okay, so this questions were based on use of elementary integration formula. Let's understand one theorem. If integration of fx is capital Fx plus c, then integration of f of ax plus b is equal to capital F of ax plus b divided by a plus c. In fact, we divide this function by what? A, which is coefficient of x. Let's prove this. To evaluate this, we use the concept of substitution. Let's substitute ax plus b is equal to t. Okay, then let's find dx in terms of dt. What is dt by dx? That is a. This implies dx is equal to dt by a. Now put ax plus b here, t, and dx as dt upon a. Then this is 1 upon a ft dt. Now integration of fx dx is capital Fx plus c. Then what will be integration of this? In variable t, that will be function of t, and we can write this as f of t plus c. If we have variable x here, we have fx, and if we have variable now t, then integration will be capital Fx. Now you can put the value of t, that was ax plus b plus c. This is 1 upon a times capital F of ax plus b, and c upon a is again a constant. We can put that as a constant, a new constant of integration. So what we understand from this formula, if we have function ax plus b, then divide the integration of fx by a. For example, integration of sin x function is minus cos x plus c. Okay, then integration of sine of 3x minus 2, what will be this? Minus cos of 3x minus 2 by 3. This is constant of integration plus c. For example, 1 upon x integration is log of mod x plus c. Then what is integration of 1 upon 2x plus 5? This is linear function, this is linear function. Here x is replaced by 2x plus 5. Then integration is what? Log of 2x plus 5 upon constant coefficient of x, that is 2. So by 2 plus c. Now using this we can find integration of next generation, like integrate sine square x. Okay, any idea? We can write sine square x as 1 minus cos 2x by 2. हो जाएगा अब ये हाफ कॉमन निकालो, then this is 1 minus cos 2x. Integration of 1 is x. Integration of cos 2x. क्या होगा इसका इंटीग्रेशन? Sine of 2x divided by 2 plus c here. Integrate sine cube x. Okay, now any formula which involves sine cube x in trigonometry, that is what? Sine 3x. Sine 3x is equal to 3 sine x minus 4 sine cube x. Then we can write sine cube x as 3 sine x minus sine 3x upon 4. Now we can integrate this by separating these two functions. 3 by 4 sine x minus 1 by 4 sine 3x. Sine x integration is minus cos x. Sine 3x integration will be minus cos of 3x divided by coefficient of x, that is 3. This plus c. Try this one. Integrate sine 3x times cos of 2x. Obviously, when we have this type of multiplication, we go for CD formula. What is sine into cos? That is sine plus sine. That is sine of 5x plus sine x. Integration of this function is minus cos of 5x upon 5, and integration of this function is minus cos x. Okay, now integrate dx upon square root of 3x minus 4. Now this can be considered as a power function. So we can write this as 3x minus 4 power minus half. Now with respect to power function integration, we have 3x minus 4 power minus half plus 1 upon minus half plus 1. This integration must be divided by coefficient of x, that is 3. Then we multiply by 1 by 3 plus c. Finally we have 2 by 3 multiply by square root of 3x minus 4 plus c. This is integration of this function. Try this question. Integration of 1 upon 3x plus 4 minus square root of 3x plus 1. Okay, now we know that when we have this type of irrational functions, we rationalize. So after rationalization we have 3x plus 4 plus square root of 3x plus 1. Okay, what in denominator? Difference of 3x plus 4 and 3x plus 1, that is 3. Now we can integrate these two functions separately. Integration of this function is 3x plus 4 power half plus 1 upon half plus 1. It should be multiplied by 1 upon 3. In fact, we are dividing by 3, which is coefficient of x, plus 3x plus 1 power half plus 1 upon half plus 1 multiplied by 1 upon 3. Next you can simplify this. Okay, some more logical questions. We have this type of trend: x plus 2 upon x plus 1 cube dx. Okay, we can have special arrangement like this. In numerator we can write x plus 2 as x plus 1 plus 1. Okay, now it's true. This ratio is x plus 1 power minus 2, and 1 upon this will be x plus 1 power minus 3. Now integration of this is x plus 1 power minus 1 upon minus 1, and integration of this is x plus 1 power minus 2 upon minus 2 plus c. Following the same trend, you can try this question. Any idea how you adjust this? We must write here at 8x plus 13 in terms of 4x plus 7. How we can write? Now this here coefficient of x is 8, here it is 4, then it must be adjusted as twice of this. So we can write 8x plus 13 as 2 times 4x plus 7. Now this is 14, so to get 13 we must subtract 1. This divided by square root of 4x plus 7. Now this is 2 times square root of 4x plus 7 minus 4x plus 7 power minus half. Now integration of this function as a power function which has power in fact half. Then this is 4x plus 7 power 3 by 2 upon 3 by 2 divided by 4, which is coefficient of x, and here it is 4x plus 7 power half upon half divided by coefficient of x, that is 4 plus c. Let's try one question like this. Integration of x square plus 2x plus 3. Any function near to this of which we know the integration? We can keep this in mind. Dx upon x square plus 1, that is tan inverse x plus c. Now do you get idea from this? Obviously we will go by completing square method. Now this is complete square of x plus 1. Balancing the constant, we have 2 here. Okay, you correct this. We can integrate this also, but we have not yet done this type of times. Make it here 2. Then here we will have 1. Now this integration is tan inverse x plus c, then this will be tan inverse x plus 1 plus c. Integrate dx upon 4 minus 3x. Now this is reciprocal function. We know integration of 1 upon x is log of mod x. Then integration of this function will be log of modulus of 4 minus 3x, this whole divided by coefficient of x, that is minus 3. Integrate now dx upon x square minus 1. Okay, we know integration of 1 upon x square plus 1, that is tan inverse x, but not this one. Can we write this as, after factorization, x minus 1, x plus 1. Now we know the integration of 1 upon x minus 1 and 1 upon x plus 1 separately. So can we separate this two? Can we write like this? 1 upon x minus 1 minus 1 upon x plus 1. This process is called partial fractions, which we study in detail later on. We have one group of integrating by partial fractions. Now here, if we take LCM x minus 1 into x plus 1, we have in numerator x plus 1 minus of x minus 1, then difference of that will be 2. So for balancing, we divide by 2 here. Now integration of this is log of x minus 1 and integration of this is log of x plus 1. Further you can simplify this to log of x minus 1 upon x plus 1 plus c. Okay, next part is integration by substitution. Let's understand this method by illustrations only. For example, consider this question from NCERT: e power tan inverse x upon 1 plus x square. Now in substitution, we always substitute for a function whose derivative is multiplied by dx. Here we can see that derivative of tan inverse function is 1 upon 1 plus x square, which is available here. Then substitution will be for tan inverse x. So let tan inverse x is equal to t. Then dt by dx is equal to 1 upon 1 plus x square. This implies dt is equal to dx upon 1 plus x square. Then we can write this as 1 upon 1 plus x square. This goes to into derivative dt, and this is e power t. Now integration of this is e power t plus c, and we can replace t by tan inverse x. So always keep in mind, we substitute for a function whose derivative is available. Integrate now sine inverse x upon square root of 1 minus x square. Obviously we will substitute for what? Sine inverse, because its derivative is 1 upon root 1 minus x square, which is available here. So let sine inverse x is equal to t. Then we can write dt is equal to, or dt by dx is equal to square 1 upon square root of 1 minus x square, or dx upon square root of 1 minus x square is equal to dt. Then this integration changes to t multiplied by dt. Now this can be integrated as a power function, that is t square by 2 plus c, where t is sine inverse x. Okay, try this one. Integration of sine 2x multiplied by cos 2x, sine 2x square root into cos 2x. Obviously we will substitute for what? Sine 2x, as its derivative is available. You can write this implies dt is equal to, derivative of this is 2 times cos 2x and multiply here by dx. Then this changes to square root of t, and what is cos 2x dx from here? That is dt by 2. Okay. Then integration of this is half t power 3 by 2 by 3 by 2 plus c, or this is, by putting then t, sine 2x power 3 by 2 by 3 plus c. Let's try some more questions, like question from NCERT, cos x upon square root of 1 minus sin x. Obviously we substitute for what? Either sin x, or we can go for 1 minus sin x, because derivative of 1 is 0. Then let 1 minus sin x is equal to t. Then dt is, derivative of minus sin x is minus cos x multiplied by dx here. Then this changes to cos x dx is now what? minus dt, and this is square root of t. ठीक है. Now integrate dx upon cos square x multiply by 1 minus tan x square. Any arrangement so that if we substitute for one function, then its derivative is available. Okay, can we write like this? 1 upon cos square x is secant square x, and this is 1 upon 1 plus tan x square. Now it's visible. If we substitute for what? 1 minus tan x, then its derivative secant square x is available. Then let 1 minus tan x is equal to t, then minus secant square x dx is equal to dt. Then this changes to minus dt upon t square or minus t square dt, that is minus t cube by 3 plus c, and then put the value of t as 1 minus tan x. Integrate now this function cos 2x dx upon cos x plus sin x square. Here we can write this like cos 2x dx. What is square of this? It is cos square plus sin square, that is 1, and 2 sin x cos x, that is sine of 2x. Now obviously we substitute for what? 1 plus sine 2x. Then derivative of LHS is 2 cos 2x multiplied by dx is equal to dt. Then this changes to dt by 2 upon t. And integration of this function is log of modulus of t. Then you put value of t, that is 1 plus sine 2x. try this one. 1 minus log x square upon x. Okay, here it's visible that derivative of log x is 1 upon x. Then we substitute for 1 minus log x. Derivative of LHS is minus 1 upon x dx. RHS is dt. Then this changes to dx by x is replaced by what? Minus dt, and 1 minus log x as t. Then this is minus t cube by 3 plus c. Then put t is equal to 1 minus log x. Then this is 1 minus log x cube by 3 plus c. Then this one, e power 2x minus e power minus 2x upon e power 2x plus e power minus 2x. Okay, this is quite visible that derivative of this function is 2 e power 2x minus 2 times e power minus 2x. Then we will substitute for what? This function st. Then we have derivative of LHS 2 times e power 2x minus 2 times e power minus 2x dx, that is equal to dt, or e power 2x minus e power 2x dx is dt by 2. Then this changes to this, and integration of 1 upon t is log of mod t plus c. Here's some more typical question. Integrate e power 2x minus 1 upon e power 2x plus 1. Okay, now you must simplify this in such a way that if you substitute for one function, other becomes derivative, and that too which is multiplied by dx. Okay, let's divide numerator and denominator by e power x. Then we have e power x minus e power minus x upon e power x plus e power minus x. Obviously now we substitute for what? This function whose derivative is available here. Try this one, dx upon e power x plus 1. Now here we again simplify this to such expression that if we substitute for one function, we have derivative multiplied by dx. Any idea? Let's divide numerator and denominator by e power x. Then we have e power minus x dx upon 1 plus e power minus x. Okay, now this is quite visible. When we substitute for this function, we find this function in derivative. Okay, try this one. Ten power 4x. Okay, any idea? One hint is write 10 power 4x as 10 square x multiply by 10 square x. Now key one 10 square x as 10 square x and other 10 square x can be written as secant square x minus 1. Now try to integrate this. This is 10 square x multiplied by secant square x minus integration of 1. Minus in fact 10 square x. This we have done earlier. We can replace this by secant square x minus 1. And what about this? We substitute for what? 10x, whose derivative is available here. So if I take this function 10x, in fact 10x as t, then this is t square and this is replaced by what? dt. Now this is t cube by 3 minus integration of secant square x is 10x, integration of 1 is x, this plus c, and then you put the value of t, that is 10 square, then this is 10 cube x by 3 minus 10x minus x in the bracket plus c. Try this one, dx upon or x dx upon x power 4 plus 1. Now here we have x available. Okay, x किसके डेरिवेटिव में आएगा? This falls in the derivative of x square. Then we can write this as x dx upon x square square plus 1. Obviously now we will substitute for what? X square. So let x square is equal to t. Then dt is equal to 2x dx then x dx is replaced by dt by 2 and this is t square plus 1. Okay, what is integration of this? Tan inverse t plus c. And this is 1 by 2 tan inverse of x square plus c. If we have this x square dx upon square root of 1 minus x power 6, integrate this. Now x square is derivative of what function? X cube. Then we can write this as x square dx upon square root of 1 minus x cube square. Now we substitute x cube as t. Then 3x square dx is equal to dt. Then this integration now dt by 3 upon square root of 1 minus t square. Now this is a standard formula for sine inverse t plus c. Okay, try this one. Dx upon x square root of x power 4 minus 1. Look for the formula which is in this type. Any elementary formula of integration? We know this one, dx upon x square root of x square minus 1 dx. This is what? Second inverse x plus c. Now here in place of x square we have x power 4. Then what we must have here in place of x? We must have here x square. Then what we will do? Multiply and divide by x. Now obviously we will substitute for what? X square. Then 2x dx is equal to dt. Then x dx will be dt by 2. And now this is standard formula for second inverse t plus c, where t is x square. Let's try some more typical equations. Square root of x upon 1 minus x cube dx. Okay, try this. If we separate this, this is root x upon square root of 1 minus x cube. Now root x falls in derivative of which function? X power 3 by 2. Then any idea how we arrange this x cube? Obviously square root of 1 minus x power 3 by 2 square. Now it's clear we have to substitute for what? X power 3 by 2. Then derivative of this LHS is 3 by 2 into x power half dx, that is equal to dt. Then this value here, it is 2 by 3 dt upon square root of 1 minus t square. Now integration of this function is sine inverse t plus c, and we can now put the value of t as x power 3 by 2.